So we're going to talk about some things about Puls. I'm not a person that reads the screen. You can all read the screen, but some things you probably know about it, some things you don't. So let's get right on with it. History: we've been around since the late 70s. Bernhard Ertl owns the company, founded it. He still owns it today. In the 80s, he started Puls, and we've been advancing ever since, as you'll see in the next couple slides. We did build on, if you look at number 3, focus, that's all we do. We're DC power systems. Tim mentioned power supplies. That's a large part of our business. We also do backup systems, buffer systems, redundancy systems, OSI systems, DeviceNet systems. So if you need anything, let us know. Manufacturing, these are our 2 plants, the top in the Czech and the bottom in China. We do make our own power supplies. There's not many people, a lot of people sell power supplies, but they don't actually make them. We actually design and manufacture either of these 2 facilities, and right now we're in this stages of building a 3rd plant in the Czech Republic. You can see on the bottom, our China plant did expand in 2017, and both plants are running with Puls personnel, even the China plant. So it doesn't matter where the power supply says it comes from, either the Republic of Czech, the Czech Republic, or China. They're made to the same standards, use the same parts, and it's the exact same power supply. Like I said, I work out of my home office. I'm in the other side of the state from Pittsburgh. I'm in Philadelphia. I cover from Canada down to DC. As you can read the first bullet point, we used to make power supplies for a company called SOLA. Heavy duty, we stopped that in 2004 because we brought our own power supplies under our own name to the market. And power, number 3 point going down, 3-month inventory. So I just had a meeting with Germany last week, and our Czech plant is fully operational. Our China plant is back online, and we have 3-month supply there, and we have 3-month supply in our Aurora warehouse, which now, since we moved almost 6 months ago now, is right next to our office. So this is something nobody else does. Everything that comes out of Puls is basically put in a heat chamber, run at 60 C, full load for 8 hours, and it's intermittent, it's turned on and off. So if it's going to fail, it's going to fail in one of these settings before it leaves our facility. Products, I mentioned some products. I probably forgot redundancy, conformal coated products. Class 1, D2, we have quite a few. DC-DC converters. Let's get right down to it. So I put this slide up first because I wanted to show you how we design our system. So everything's done thermally. We pride ourselves in our efficiency, and that's what people know us for: efficiency, long lasting. So if you make an efficient power supply, it will last longer because we're not heating up critical components. As you can see from this thermal image, the power supply sits the way you would see it right there. Number 1, that large circle, is our input cap. It's designed to be placed right in the bottom because that, with anybody's electronics, electrolytic capacitors are a failure item, so you want to keep them cool. So that's the input cap. We make it big. It can take a lot of abuse, can take a lot of spikes, and that thing gets abused constantly by the AC mains power coming in. So coming up for that window pane objects, our transformer, and then our inductors up at the top. 2, 3, and 4 are electrolytic caps, and number 5's that's a flat cap. It's not electrolytic, it's a flat cap. But you want to keep all your caps cool because they are, especially electrolytics, are a failure item. And we keep them in the area of the cool flow coming in the bottom. So it acts like a chimney. Cool air comes in the bottom, the heat goes out the top. So we have a new series out, the CP series. So did we eliminate anything or obsolete anything? Absolutely not. There is talk later on this year, possibly the Silver line, which is a at least 20-year-old product, if not older, will start to go away because, number one, we don't sell a whole lot of them. And number two, we have direct replacements for everything. So I think that may be retired. But CP5 series is coming out. The Q series is still available. The CS series is still available. So in the past, the C series would be the CS. So what's the difference between the CP and the CS? Number one, if you look 5 up from the bottom, the CP has active power factor correction. The CP is actually smaller, but in this particular model, it's the same size, 32 millimeters for 5 amp, because we didn't want to reduce the size of carrying capability. I keep carrying. I think we may want to mute our phones and computers. So the 5 amp will put out 6 amps continually. The caveat is the temperature is between -25 and plus 45 C. At those temperatures, it will put out 20% more. At 46 C up to 60, we recommend staying at a 5 amp just because of the heat buildup. You can see, so the efficiency is higher than our CS. The active power factor correction is added. It also has a DC OK relay contact, which the C series does not. And this is available if you look at the second up from the bottom, UL, you see on the very right, UL 508. That's going away for power supplies. The new UL standard is 61010-2-201, which has more to do, I'll go back a screen, to this above number one, this window pane object, the transformer. In the past, power supplies were linear 50, 60 years ago, when 508 came out and UL said, well, it's a power transformer, so that's UL 508. So the linears had a transformer and an H bridge on them, and you would adjust the transformer connections to your input voltage. Now, as you can see, the size of the transformer is greatly reduced, and it operates more now because of the microprocessors as a computer. So it's 61010 is not for power transformers anymore, but that's the new UL standard for power supplies. On the bottom left, I show on the bottom, I'm sorry, let me go to the bottom. Top left is our CP5. The bottom left is a redundancy module for that power supply. So new series, we have a 12 volt output option. And all these, by the way, are 100 to 240 volt AC input. They also take a 110 to 150 volt DC input. So you take an AC or a DC. So why would you need a DC input? People running redundancy sometimes want to run one power supply off an AC, another power supply off DC. So you can put 10, 12 volt batteries in series, got 120 some volts, 128, 130 volts, run that into another power supply and take both outputs in the redundancy module. So if you lose a main AC and it's a very critical application, you still can run your load. So 12 volt output, a lot of 24 volt output, conformal coated spring clamps, push-in terminals. Second up from the bottom, we can take a DC input of 100 to 300 volt. Some of the rail industry likes the higher DC voltages. Some of the servers, data rooms like the higher DC voltages because they run off batteries. And last but not least, we have a 48 volt version available. So that's our CP5 series. CP10, just a little bit more power, same input power, AC and DC. Now this is 39 millimeters wide. The one it replaced, the CS10, was 60 millimeters wide. So This is reduced 21 millimeters in size. Efficiency's up. The same reserve power, 20%. Again, active power factor correction. This also has a DC relay output, and it has the same UL 61010, 61010-2-201. Class 1 D2 is also available with this. You see on the top, there's some different terminal configurations. The left is the regular screw terminals. The next one, the center one, is our spring clamps, and all the way to the right is the push-in terminals. Size comparison between us and them. Huge difference in size for all 240 watts, 10 amp, 24 volt power supplies. So this one's available in 12 volts, 16 amp output, and you'll see a lot of different 10 amp models. C1 is conformal coated, M1 is a medical power supply, medical grade. R1 has redundancy built in, spring clamps. R2, redundancy, removable terminals, which is in the top left. So if you have a power supply go down, you'll have two of these. You don't need a redundancy module. Two of these wired in parallel to the load. If one power supply drops out, the other power supply takes over. And it doesn't backfeed because the redundancy is built into the power supply. So in the past, if you needed redundancy, some people would say, well, just put two power supplies in parallel to a load. That would work. However, if one power supply was short, you would lose that power supply, and the other power supply, putting all its load into a dead short, would turn itself off to protect itself. So in theory, you lost both power supplies. So that's why we had redundancy modules to take the one power supply that failed out of the circuit. This power supply has redundancy built in, so you would need two of these wired to your load. Next one down, R2C1, same thing as I show here, except it has conformal coating. And then we have two different spring clamps and push-in connectors. Push-in terminals use a spring wire on the very bottom on the left. You do need to put a screwdriver, a small screwdriver, in a hole on the bottom to push the wire in. So just kind of show you a difference between, in the past, what we would do for redundancy. These are the 20 amp models. At the top, I say 10 or 20 amp because we have these available in 10 or 20 amps. But the ones I'm showing in the picture are 20 amps compared to our standard 20 amp redundancy setup. Space savings is huge with these built-in redundancy modules. Again, just the big brother or big sister, whichever you prefer. Minus 40C operation for the redundancy units, DCOK contact, the same power, so 20 amp continuous, 24 amps minus 25 to 45C is 24 amps, and you can run it constantly. Again, when you get over 24 amps, you don't want to have a load greater than 20 amps just because of the heat buildup. We'll take the wide, extended range DC input, 110 to 150 volt, and it is only 48 millimeters wide. The one that was before this was 65 millimeters wide, so you're saving a lot of room here, especially if you need redundancy. If you have a critical application that can't go down, it costs a lot of money if it goes down. Some of the utilities are like that. Some of the where it's very expensive to go down. Some of the medical, bioreactors are making drugs that millions of dollars in a bioreactor if something goes down. So those type of applications, people want redundancy. So if the cost of a application, if the cost of the product is greater than the cost of a redundancy module, then that's when you should look at redundancy. CP20 available in different configurations. The bottom we have 48 volt, We have the third one up is a V1, which is something new. V1 is a remote on off. So the input stays on. It turns the output on and off by giving it a 24 volt signal. Somebody must have asked for this. That's why we have it. Second up from the bottom, we take 100 to 300 volt DC and supply 20 amp output. So this is a series that was developed for people to say, Mike, I really like the power supplies. I like the philosophy. I like what Puls is doing. I just don't need all that. I just don't need the long life. There's long of the life. Maybe the efficiency, maybe the size. These are slightly larger, the efficiency slightly less. However, these last an incredibly long time. The reliability is extremely high compared to our competitors in the same models. So these are for the people to say, I'm using automation direct, it gets me by. This is a step, certainly a couple steps up from that. The pricing is very close. This is to replace the Meanwells, the IDEX, the automation direct that people say, well, I just need something cheap. It's got to last me a year. These will last way more than a year. We show for all our power supplies the life expectancy besides MBTF. So we know how long we expect these to last, and we can show that where our competitors don't show that. Doesn't offer current reserves like the other ones, no 20% current reserves. This is for somebody that just wants something. They need 5, 10, or 20 amp, and just to get that job done, and don't need a lot of frills. So it does a great job with that. It's slightly larger than the CP series, and it costs less than the CP series. So I'm putting this out there. This is a DC-DC converter. In the past, we had this model available in 5 amps, so that's the model number was a CD5.241 at 24 volts. So this takes 24 in, gives you 24 out at 10 amps. So it seems kind of silly, right? Why am I taking 24 in and 24 out? These work great because they're galvanically isolated, so any dirt noise coming in will not go out the output. You'll have a straight DC output signal coming out of this. It's also used for long runs. You have a light, you have another system, remote system. It's a couple hundred feet away. You're running 24 volts. You can't run AC out to it for whatever reason. By the time a couple hundred feet, your 24 volt signal, even though you crank it up to 28, 29 volts, it gets out there, it's 18 volts. Hook it up to this, and you got 24 volts again. So it's for kind of boosting the signal, and it's also to eliminate any noise coming in the DC line. Here's an example of our lifetime, the third bullet point down. Again, we show lifetimes on all of our products. This is what we as the manufacturers say it will last, 103,000 hours. I'm showing this because a lot of people now are getting into backup systems. I think they're starting to see the benefit of a DC backup. So we make DC backup systems. And I specify DC because everything Puls does is a DC output. We don't have any AC outputs. So if somebody says, I'm running I have a backup, but it's AC, it's an APC system. I plug it in. So let me tell you about an AC backup system. You're taking AC from the mains. You're converting AC to DC. The DC, you're charging a battery. And then you're going through from the battery to an inverter, converting the DC back to AC. So it's very inefficient. These are very simple products. They take DC in and they give you DC out. You can see the one on the left, bottom left. That's a 5 amp hour battery with a DC UPS. We also make other models. We make up to a 20 amp. We have 4 that are 10 amp outputs. We have one that gives you 24 volts out and also 12 volts out. That was designed for the wastewater people. The old radios, the Motorola radios, were 12 volts. So when they upgrade their systems, they didn't want to necessarily have to replace the radios. So we made an output that would support the Motorola 12 volt, the older systems. So, and you see we sell some batteries on the right. We're not a battery manufacturer. We go up to 26 amp hour. I know some of the gas and oil people want, 100 amp hour, 150 amp hour. We don't supply those. Again, we're not a battery manufacturer. We have these available for convenience for our customers. But we can take, say, for instance, the one on the bottom, the 20 amp, we can take 200. It's actually up to 150 amp hour batteries now, and give you a couple days at an amp and a half. This is showing the output of the one with a built-in battery system. We can supply 6 amps, and we're saying, 10 amps. We're saying for about 6 minutes. You don't want to run it all the way to 6 minutes. I would say 4 minutes max, because you want to leave some overhead for the battery. You don't want to take it all the way down. But this is great for somebody that needs a backup. The power goes out. They want to do a sequential shutdown of their PLC or PC, maybe gather some encoder points or process points, send a signal out, and then start a shutdown of their system. It's perfect for that. This unit, by the way, on the DIN rail, as you see right there in the picture, is less than 5 inches wide with a battery. You see UltraCap backup system. This is instead of using batteries, this uses capacitors. We have, you go back to this, we have 2 models available. The 241, my cursor's on 242. The difference is the amount of capacitors internal. So the 241 can put out 6 amps for about 30 seconds, and the larger one can put out 6 amps for about 60 seconds. So it's about double. Most people only need less than 2 amps to do a PLC backup. Has more than enough runtime to back up if you're running a PC, Windows 10 takes about 70 seconds to back up, draws about an amp and a half, so you got plenty of time to do a backup on a Windows-based system or a PLC. And the chart to the right shows you the runtimes. Nice thing about this is we're batteries that don't like the cold weather. UltraCaps can operate down to a -40, which is great. They can go outside. They can go inside a control cabinet, a metal control cabinet, without having issues with outgassing, because there's no outgassing. These will put out 15 amps. Most people don't need the large amperage output, but they need their runtime, and just a couple amps over, a minute or so, just to do a shutdown. I think we covered everything here. So future products. Where are we with future products? So these are 2 new products. They're going to be coming out within the next 6 months. Zero Cabinet is our IP67. It's unlike anybody else's IP67 that it will not be potted. If we looked at the injector to the right and pretended that was a power supply, which there is a power supply in there, and the top screens that you see, and there's bottom screens like the same way, and if we would fill that with an epoxy material, that power supply, which is I know is a 20 amp, would have a maximum output of about 2.5 amps, because the potting material would not allow the heat to escape. So the unit on the left, the Zero Cabinet, is not potted. It's an aluminum frame. It's vented. There's fins in the back. It can also be mounted on a DIN rail, or as you can see on the left and right side, there's screw holes. This is made to be mounted outside the cabinet. Reason being is a lot of the big retailers, automotive, realize that if they need to open a cabinet up, it costs them a lot of money. Somebody has to suit up, takes money, time to do that, go in the system, something happens, God forbid, there's, could be liability issues. So now if a power supply would go down, they have these mounted on a board outside the cabinet with circuit breakers next to them. You throw the circuit breaker, turn it off. This particular one has hardening connectors. The input is in the center. It's a 7/8 inch input. The outputs are hardening connectors. This will be for automotive. We'll have ones with M12 outputs. We'll have multiple M12s, so at 20 amp, maybe we'll have 4 channels of 5 amp or 2 channels of 10 amp. In the future, these will have I/O link available, so you can actually look at the innards of the power supply, the heat output, the length of time on, the loads, the input signals, and this will then determine the projected life of the power. Is exactly what Amazon and Walmart and Target and all the big retailers, online retailers want. They want to do predictive maintenance. So I/O link added to this will help with that. Also, they would use this because they can run long AC runs, right? These plants are huge, million square feet. So DC, as I said before, after a couple hundred feet, the signal starts to go down. It's unusable. You can run AC through the plant and just tap these off the conveyor system. Every so many feet, just have a IP67 cabinet. To the right, this is an 8-channel PoE injector unit. We'll have 2. We'll have this is the AC in, as you can see on the bottom, neutral and L in line, and we'll also have a DC at 48 volts in. So this will put 48 volts out, adjustable up to 56 volts, 8 lines in and 8 lines out. So for cameras, for sensors, you can put them off of this, and this will provide the DC to power the cameras and also pass the data through. So the other thing I wanted to point out is our website. And I wanted to show this for a reason, because it's very easy to go to our system. First thing you have to do, it comes up global here on the right. You don't want to be in global. You want to be USA. And the reason for that is you're going to see some products in global, like the PoEs, that are going to be available. Yes, they are available in Europe right now. They're not available in the US. Why? Because it has to go through UL 61010, and they're not through that yet. So as soon as they're available, they will be on the US site. Product search, you can look up here, applications, products. If you go to the right, this blue oval box, product search by part number, you can do a product search by the AC, by the input. Is it AC input? Is it DC input? Do I have a DC input? Output voltage, output power. You want to look at buffer modules? You want to look at I/O link modules? Well, they're not available today. So I want to look at a certain class. So I want to look at class 1, D2. Let's see what we come up with. I'll just click that. I'm not going to click up any other. So these are all class 1 div 2. These are some power DC to DC converters. So it takes DC in. These all take DC in and give you a DC out. These are all AC in power supplies, single phase power supplies. These are all class 1 div 2. And if I go down, all the way down, different Q series gives you 50% current reserves instead of 20%. And if I go to 3-phase systems, there were single phase up top, there's 3-phase, and there's an Aussie power supply if you need it, and device net power supplies. And here's redundancy modules that are C1, D2. So we have a lot to offer. If we can help you with anything, please let us know. Tim, I think my time is up. If you have anything you want to share?
We did have one question out there about can I eliminate cooling in my enclosure if I use a Puls power supply? We can address that.
Yeah, you know, I can't say because I don't know how much heat's in the enclosure. If you get back to Tim and kind of give him an idea, you know, what's in there, what we need to know. I mean, we can actually size the power supply for your enclosure. The size of the enclosure, the BTUs, what's in there, what's giving off heat, and is a fan or, you know, is it there a fan or no fan? we can help you with that. So sure, be more than happy to help you. Our power supplies, like I showed you, 95% efficient. So at 20 amp at 95%, that's 480 watts. Just doing quick math, because that's all I can do. So 480 watts and 5% to heat is about 24 watts. So the power supply at full load is losing about 24 watts to heat, which isn't a lot for a 20 amp power supply at full load. So yeah, I'd be more than happy to help you with that. Possibly we can, but without knowing your specifics, you know, I don't. If you have a lot of drives in there, anybody's power supply is, you know, is nil, putting out nil compared to the drives you have in there. So yeah, get with Tim, and we can certainly you know, help you with that. Size it out, let you know what we have.
Okay.
Well, I want to thank everybody for coming. Tim, I know wants to say a couple words, and we'll enjoy it. Be safe, everybody. It's scary times out there, so be safe, and we'll talk to you soon.
Okay, yeah, and if anybody wants a copy of the presentation, they can email or text me. But thank you again from everybody for coming, and everybody have a great weekend.
Yeah, take care, everybody. Bye-bye.
You too.